Hi AMP students, welcome to my channel. In this video I'm going to be going over hemostasis, also called blood clotting. Because we are doing this online, there are going to be some specific things that I want you to know from this. You won't have to know the entire process, but I know some of you need to know the entire process in order to understand the specifics that I'm going to ask you to know. So I'm going to do all of that for you. I'm going to walk you through like a little model of this so that you can have the opportunity to learn it all the way through if you want to do that. And then at the end, I'll kind of point out what my things are that I really want you to know. Before I explain the model, it's important for you to understand that when we're talking about blood clotting, we're talking about the clotting that happens when you get a cut in your blood vessel. This kind of blood clotting is something that we want to happen. It is a good thing because you want to close the blood vessel wall to prevent loss of blood. This blood clotting is different from agglutination that happens with blood transfusions, which is bad. And then it is also different from blood clotting that happens when you get like a clot in a vessel where the red blood cells have clumped up together because of buildup in like plaque buildup in the blood vessel walls. This hemostasis, this kind of blood clotting is good. We want this to happen so that we don't bleed out externally or internally. First, I'm going to tell you what all the important parts are for hemostasis. These pipe cleaners will represent collagen fibers. These lentils will represent platelets. These beads will represent the hormone serotonin. These little elbow macaroni are going to be our tissue factor. Some videos will call this factor 10A, but you can just call it tissue factor. This little doohickey thing is going to be prothrombin. When it is activated later, it will become thrombin, which is super important. And then something else, which, whatever. Then lastly, we're going to have these little strings will be fibrinogen, which gets converted into fibrin later. Okay? All right, so here's my blood vessel that I've made, and then here's my opening in the blood vessel. We're losing blood very bad. It's important for us to note that all of those other components, like the fibrinogen, the prothrombin, the tissue factors, et cetera, those are all just like floating around in your bloodstream just normally, just waiting to be activated. So the first thing that happens in blood clotting is the formation of something called the platelet plug. So when the blood vessel wall opens, these collagen fibers are exposed and platelets will stick to the collagen fibers. So they start making a clot over the opening, and they start getting, as they stick to the collagen, they'll just start getting like stickier and stickier so that they bring in more platelets to make the clot. As they're doing this, this will also activate serotonin to come in here. And serotonin, the presence of serotonin, that hormone, will cause the blood vessel wall to constrict so that you don't get a further loss of blood. So it makes the blood vessel wall smaller so that you're keeping as much blood as you can in that area. These little serotonin beads keep rolling everywhere, so I'm just going to put them off to the side, but serotonin makes the blood vessel wall get smaller. As the platelets are calling in serotonin and becoming stickier, they're also going to call in these little tissue factors. And so depending on what kind of video you watch, there's like a really long process to get your tissue factors activated, but we don't really worry about that. So these tissue factors will come in and they start activating. These are like our little prothrombin activators. So this prothrombin that we had from the beginning, these tissue factors will start activating this molecule, and it basically separates it out. So now we have thrombin, which thrombin is the key to making your blood clotting process continue to happen. So thrombin is an enzyme that is going to take our little pieces of fibrinogen, our fibrinogen molecules, these proteins, and this enzyme thrombin is going to take those fibrinogen proteins and it's going to bind them together. I'm tying a little knot here. Bind them together to make longer strands, and this is going to be called fibrin. Fibrin is ultimately what starts making our net that traps even more platelets and then basically covers the whole covers the opening in the blood vessel wall. Okay? Okay, so just to recap, the collagen fibers are exposed when the blood vessel wall is open. The platelets bind to the collagen. It activates serotonin to vasoconstrict or constrict the blood vessel walls. It also activates these tissue factors. These tissue factors will activate prothrombin. Boop. Now we have our enzyme thrombin, and thrombin is going to take fibrinogen and convert it into long strands called fibrin to make a little net that goes over the opening in the vessel wall, thus preventing further blood loss. Overall, the most important things to know about hemostasis are listed here. Again, I went through the whole process with the model because I know some of you understand things better when you see the bigger picture. But pulling out the most important stuff that you need to know, the first thing is that platelets will stick to the collagen fibers, and this makes like a little platelet plug or a clump of platelets. The second thing is that the serotonin causes the blood vessel to constrict, which reduces the loss of blood. And number 3, coagulation will happen. And the most important thing to know here is that thrombin converts fibrinogen into fibrin. And then the fibrin net traps the red blood cells. So I know on your list from this, you had a lot of other stuff that was on here. But the most important things as far as function are going to be collagen, serotonin, thrombin. And that's converting fibrinogen into fibrin to make the fibrin net. Thrombin is an enzyme. So you might see it described as that in work from me or in other resources that you look at. All right, so I hope this video was helpful for you to figure out what's the most important stuff that you need to know about hemostasis. If you have any questions, please email me. And don't forget to like and subscribe.